Under a soft, cloudless sky, night settles over Earth like a slow, dark curtain. One by one, familiar stars appear. They blink and shimmer, tiny fires burning across a vast, cold distance. Near the horizon, almost easy to miss, a faint rust-red glow rises. It is not bright, not sharp, not loud. It is a quiet brushstroke of color against the dark. This is Mars, the red lantern in the dark, lifting itself into view as it has for millions of years. From ancient deserts and stone temples, people once watched this same light and felt a strange unease. Mars moved differently than the fixed stars. It wandered. It brightened and faded. To early sky watchers, it looked like a celestial wanderer with a will of its own. They named it after gods of war and fire. They feared that its reddish shine was a sign, a warning, a harbinger of trouble on the way. Tonight, though, there is another way to see it. The red lantern is no longer just a symbol. It is also a clue, part of a system of watching and measuring that stretches around our planet. Telescopes in deserts, on mountaintops, and in orbit trail their gaze across the sky. Cameras cool themselves to deep, silent temperatures to catch the faintest flicker of motion. Computers compare one image to the next, hunting for tiny changes. Somewhere in those changes are the paths of ancient travelers. Comets, asteroids, fragments of rock and ice drifting on long, lonely trajectories through the dark. If you are listening now as you drift towards sleep, you are part of this watching too. Take a slow breath. Let your shoulders relax. If you'd like to keep traveling through these night stories with me, subscribe and share where you are and what time it is. I read them: Karachi at midnight, New York before dawn, Tokyo in the afternoon, like new stars lighting up across the earth, each one a reminder that we are looking up together. On some nights, when Mars stands high and clear, observatories turn their mirrors toward it, not only to study the planet itself, but to study what passes near it. Mars does not shine by its own light. It reflects the sun the way our moon does. But around it, and in the space it shares with us, small bodies move. Icy comets, rocky asteroids, dust clouds that glimmer like ghostly veils. When these objects swing near Mars, their paths can be measured and traced. Astronomers use careful math to follow each orbit, to see whether any of those paths might, someday, cross our own. Every orbit is a story. Some are wide and slow, looping far beyond Mars into the deep cold, where sunlight is only a thin memory. Others are tight and quick, cutting inside the orbit of Earth, racing close to the sun, then flung back outward again. Telescopes catch them as they move, a few pixels against the star field. Spectrographs stretch their light into rainbows, revealing what they are made of: iron, nickel, carbon, silicates. From that light, scientists learn whether a rock is dark and porous or bright and metallic. It is all very calm, very precise, and yet behind this quiet work is a simple, powerful reason. Every measurement around Mars is also a rehearsal. It is part of a hidden drill for the day when a bigger object shows up on the sky maps, pointing not past Earth, but toward it. The astronomers who map Mars's neighborhood are like guardians at the edge of a town, watching the road at night. They are not afraid every moment. They are simply ready to notice the one stranger who does not pass by, but keeps coming. On the screens in those silent control rooms, Mars is often just one more point in a moving pattern. Charts show the positions of planets, their orbits drawn like nested rings. Dotted among them are the bodies that do not glow on their own. They are dark until they cross sunlight or reflect just enough starlight to be seen. Others remain unseen, hidden in the glare, waiting for a better telescope, a wider field of view, a longer exposure. Each new camera, each sharper spectrograph, pulls one more stone traveler out of the dark. From your place on Earth, you feel none of this motion. You lie back or sit by a window, and the world seems still. Yet you are moving with the planet, carried on a spinning sphere that orbits the sun at tremendous speed. The moon circles you. Mars loops further out. Beyond that, the wide belt of asteroids stretches like a broken ring. Our whole system turns inside a galaxy of stars, each with its own swirling debris, its own old fears and fragile hopes. Sometimes, when a new asteroid is discovered near Mars, there is a brief, private moment of tension. Computers project its path forward, year after year. Lines of code ask the same question: does this come close to Earth? Most of the time, the answer is no. The orbit sails safely past. The object becomes another harmless entry in a long catalog. But once in a while, the numbers tighten. The projected path brushes nearer, and human eyes study the plots again, looking for certainty. We do this because our planet carries scars. In deserts and oceans, on high plateaus, and buried under ice. Evidence remains of past impacts, craters wider than cities, shocked minerals formed only in sudden, violent pressure, thin layers of dust and ancient rock. Some of those events changed the climate. Some reshaped the story of life. One of them, long ago, ended the age of the dinosaurs and cleared the way for mammals, and eventually for us to rise and wonder at the sky. Now, under the same sky, the work of watching is an act of memory and of care. Old fears linger in the background, the fear of sudden fire, of a sky that falls, of a world that changes faster than we can adapt. But alongside those fears is something else, a growing skill, a patient understanding of orbits and trajectories, of how to listen to the cosmic whispers around Mars and around Earth. The telescopes and radio dishes do not panic. They simply collect light night after night, turning the unknown into maps and the unexplained into measured paths. Mars, the red lantern, hangs in this story like a marker at the edge of a field. It reminds us that we are part of a system, not alone in empty space. Planets pull on one another. Comets are nudged off course. Tiny changes in distance, speed, and angle can send an object along a new route, across the invisible border between harmless and dangerous. What we learn from Mars's sky, the slow drift of debris, the rare close shaves, the soft glow of dust in its thin air, helps us understand our own sky better. If you step outside or simply imagine it now, picture that rust-red point again, just above the horizon. Think of the centuries of eyes that have watched it, filled with stories of war and omen. Think of the modern lenses that now, in quiet rooms, watch alongside you. We stand in the thin space between fear and preparation, between superstition and science, learning to read the night with clearer eyes. The starlight continues to fall, gentle and steady. Mars climbs a little higher, then higher still, following its age-old path. Around it, and between us, ancient travelers move on their long, dark journeys, some known, some still hidden in shadow. The telescopes keep their silent guard. The data streams whisper across the world. And in the spaces between each measured point, in the darkness that our instruments have not yet touched, there remains a question, drifting quietly, waiting for someone to notice it. Night falls over a world without streetlights, without phone screens, without the quiet hum of machines. Above a desert or a grassy plain or the deck of a small wooden ship, the sky is the only ceiling people know. In that wide cradle of silence, one light draws the eye again and again. It is not the brightest star and not the largest pattern. It is a tiny, steady ember glowing with a soft red hue. The ancient traveler does not know its name, but feels its presence. That red star seems to watch back. Night after night, people notice it. They see how it rises at different times of the year, how it sometimes shines brighter, how it slides along a strange path among the other stars. It does not stay fixed like the patterns of the constellations. It drifts, it wanders. In time, as stories grow and languages form, it earns a special place in human memory. This wandering red point becomes a harbinger of things to come. Long before telescopes and spectrographs, long before anyone can measure an exact orbit, the sky is a book that only trained eyes can read. In Mesopotamia, scribes pressed symbols into wet clay, recording careful notes about the red star's position. In ancient Greece and Rome, it is linked to the gods of war, a crimson spark that seems to match the color of blood and fire. In distant China, court astronomers study its motion with quiet focus, knowing that a report about a strange anomaly in the sky might change a ruler's plans. Everywhere, people feel that this red light is not just a point of starlight. It is a sign. Mars moves in a way that confuses anyone who watches closely. Most stars march across the sky in clean, simple lines, rising in the east and setting in the west. But this red wanderer does something odd. Against the background of stars, it sometimes seems to slow down, stop, and then move backward, tracing a gentle loop in the sky before continuing on. This strange trajectory is called retrograde motion. To people without modern science, it feels like the planet is hesitating, turning around to deliver a hidden message. Priests and seers take note. When the red star brightens, they link it with battles. When it hangs low and dim, they whisper of sickness or drought. Over time, comets, meteors, and planets like Mars blur together in the human imagination. A comet appears as a ghostly streak, a comet tail like long hair sweeping across the heavens. A meteor burns for a heartbeat, a sudden falling star that startles anyone awake enough to see it. Mars glows softly, refusing to vanish, steady and patient. Together, these sights form a pattern that feels forbidden, like writing in a language that only the gods understand. Imagine a night when a comet rises, a shower of meteors flashes, and Mars burns red near the horizon. To us, it might be a rare and beautiful alignment. To ancient watchers, it is a storm of omens. They gather their leaders. They change travel plans. They delay a war or rush into one. The sky becomes a kind of weather forecast for the soul, predicting fear and hope instead of rain and sun. Even when nothing happens on Earth, the memory of that glowing red star sticks in their minds. The story grows, retold around fires and in temples. From our point of view now, the mystery is gentle and clear. Earth and Mars are like two runners on an invisible track around the sun. Each world follows its own orbit, its own path in the dark. Sometimes Earth moves faster, catching up and passing Mars. When that happens, Mars seems to drift backward in our sky for a while, even though it never really turns around. Retrograde motion is not a sign of war. It is a trick of perspective, a simple result of moving worlds and changing angles. What once felt like a cosmic whisper of danger is, in truth, the smooth dance of planets. The changing brightness of Mars has a simple cause too. When Mars and Earth are on the same side of the Sun and close to each other, the red planet looks big and bright, its glow intense even through the haze of Earth's air. When the two worlds are far apart, with the Sun between them, Mars grows faint and tiny. No hidden gods are at work there, only distance and light. The thin air of Mars reflects sunlight back toward us, and our eyes, sensitive in the darkness, turn that faint signal into a feeling: awe, worry, wonder. Yet even when we explain the science, the old emotions do not fully fade. There is something fragile and human in the way our ancestors looked up and searched for meaning. Without knowing about orbits, gravity, or exoplanets circling other suns, they still sense that the sky is connected to their lives. The red star becomes a messenger because people need messages. They need patterns to guide their choices, hope to calm their fears, and stories to soothe their long nights beneath the drifting shadows of clouds. In time, telescopes appear. Glass lenses bend starlight into clearer images. The red star is no longer just a point. It is a tiny disk. Later, spectrographs spread that light into stripes and lines, clues about what Mars is made of. Scientists learn that the planet is a real world with rocks, ice, and thin, cold air. It is not a burning coal, not a wandering god, not the lantern of a spirit. It is a neighbor. The old omens lose their power, but the sense of mystery does not vanish. It simply changes shape. Now, as you rest and imagine the night sky above you, Mars hangs there as both legend and lesson. It reminds us how easily we can misread the universe and how patient the universe is with our mistakes. What once warned of war now invites questions about life, water, and ancient rivers frozen in time. The red star no longer tells kings when to attack. Instead, it quietly offers data to small machines and orbiters, to rovers that roll across its dust like careful guests. Somewhere between those ancient fires and our modern screens, Mars shifts roles. From harbinger of doom, it becomes a guide toward deeper understanding. The same soft glow that once stirred fear now carries a different kind of message, one written in mineral clues, dry valleys, and thin wisps of cloud curling above a rust-colored desert. As you drift towards sleep, you might picture that world turning slowly in the dark, a tiny ember in a vast nebula of stars, still sending its silent signal across space. The omens have changed, but the sky has not. And in that quiet glow, there remains the feeling that Mars is still a messenger, waiting for us to decide what, exactly, it has been trying to say. High above the quiet night side of Earth, the sky looks calm. You can imagine yourself lying under that sky, watching a small red star shine through the soft glow of starlight. For most of human history, that red point is a sign, a harbinger, a fiery god of war. Now it is something else. It is a neighbor. It is a place with machines circling and crawling, watching in patient silence. Mars has become the silent observatory next door. Far from the noise of cities and the rush of oceans, Mars turns slowly in the dark. Thin clouds drift like a gentle veil over rusty plains. Around it, silent shapes move along careful paths. These are the orbiters, each one following a precise trajectory, their motion planned years in advance. They do not blink or sleep. They loop again and again, tracing long ovals and tight circles around the planet, always watching. From their windows, no glass, only instruments, these orbiters stare down with unblinking eyes. Cameras sweep across craters and canyons, catching every drifting shadow as the sun glides over the curved horizon. Other tools ride beside them, a spectrograph that breaks sunlight into colors, a sensor that feels the whisper of the solar wind, a radar that sends pulses deep into the ground. To you, this might all sound like quiet magic. To scientists, it is data. To Mars, it is attention. Each orbit, each pass, is like a slow scan with a giant telescope dragged close to the target. You can picture it, the red planet filling the view, then sliding away, then returning again and again. In every pixel, in every faint change of brightness, there are clues. The orbiters read the light from dust and rock, from frost and thin air. The spectrograph turns that light into lines and patterns, a code that tells what minerals sit on the surface and what gases float in the sky. Mars does not speak, but its reflected light becomes its voice. Down on the ground, in that dusty world, other machines move even more slowly. Rovers crawl across the sand on careful wheels, feeling their way like old explorers with tired feet. Their tracks are narrow scars across untouched soil. Fine grains puff up around them, forming tiny storms that fall back in slow arcs. The air is so thin that each grain seems to hang, caught between falling and floating. as if the whole planet is moving in a dream. A rover raises its camera mast and looks around. The sun is smaller here, and its glow is soft and pale. Shadows are sharp and long. In that quiet, every rock looks like a fossil thawed, frozen in place for ages. The rover's cameras capture these rocks in crisp detail. Its spectrograph tastes them with light, looking for hints of past water, searching for the delicate minerals that form only when liquid moves and rests. Every scan, every small drill into stone, turns Mars into a living laboratory. Unlike Earth, Mars hardly hides its wounds. There are no wide oceans to cover its scars, no forests to grow over old craters, no thick, swirling weather to erase the past. The atmosphere is thin, more like a ghost of air than a true blanket. Rain does not fall here now. Rivers do not rush and carve deep new channels. Mars does change, but slowly, almost shyly. This is why scientists love it. What falls on Mars tends to remain. Imagine a comet, an ancient traveler of ice and dust, crossing the inner solar system long ago. Its path bends near the sun, its tail glowing like a tiny nebula stretched thin by light. On one pass, its trajectory brushes Mars. There is a flash, a shock wave, a crater punched into the ground. On Earth, such a scar could fade with time. Wind, water, and moving plates reshape the land until the wound is blurred. But on Mars, with its fragile air and its still crust, that crater can sit for millions, even billions, of years. From orbit, those craters look like fingerprints pressed into clay. Some are small, hardly bigger than a house. Others are so wide that entire cities could fit inside them, with room to spare. Rings and raised rims show where the surface was lifted and broken. Dark streaks mark where landslides once poured down the walls. Layered rocks at the center tell of shock and heat. Together they form a quiet archive of disaster, a timeless memory etched into stone. Because Mars keeps these memories, scientists can read its surface like a long, scattered timeline. The older, more crowded regions, filled with overlapping craters, speak of violent ages when impacts were common. Younger, smoother plains suggest later calm, where fewer messengers from deep space reach the ground. By counting craters and measuring how worn they are, researchers can estimate how old each surface is. The planet is not just a world. It is a record of how the solar system has changed. But Mars is not fully frozen. There is motion, even in this cradle of silence. Dust devils twist across the plains like wandering spirits, leaving dark tracks that fade with time. Global dust storms rise from small gusts until the entire planet is wrapped in a tan fog. The thin air still carries the solar wind, charged particles streaming from the sun. With so little protection, that wind strips away bits of the atmosphere, grain by grain. The same force that once made Mars more Earth-like slowly peeled it back down to what it is now. The orbiters feel this invisible storm. Their instruments measure how the air thins at the edge of space, how particles escape into the darkness. They track the way day and night change the upper atmosphere, how solar flares push and pull on it. Each reading adds another line to the story. A once thicker air, slowly lost. Perhaps running water, slowly gone. A world shifting from possible seas to dry deserts. On the ground, rovers listen too. Their microphones pick up the faint hiss of winds moving around their bodies. Their seismometers can feel the tremors of Marsquakes, tiny shakes that hint that the interior is not fully dead. The data travels back across millions of miles, turning into graphs and numbers on screens. In quiet rooms on Earth, people sit late at night, looking for anomalies, for unexplained patterns that might tell of hidden ice, buried lakes, or new kinds of rock. Mars is thus not only a subject, it is a partner in a long, patient conversation. If you close your eyes now, You can picture yourself drifting above this scene, as if you are another silent orbiter. Below you, rover tracks write thin lines across the sand. A crater opens like a dark eye. The sun glints off a distant hill. There is no sound except the whisper of thin air sliding over stone. This is not the loud drama of crashing worlds. It is the slow, gentle work of watching, of paying attention, of letting a distant neighbor tell its story at its own pace. Far beyond Mars, other worlds circle their stars. Telescopes on and around Earth search for each exoplanet, measuring tiny dips in starlight as they pass. Their skies might hold thick clouds, raging storms, or calm oceans. We cannot yet see their craters or count their scars. But Mars, close enough for rovers and orbiters, offers a guide. It shows how a small planet can change with time, and how the marks of that change stay written on its face. In this way, Mars becomes a mirror. When we look at its broken surface, we see not only its past, but also a reflection of our own world's fragile safety. Earth has been struck before. It will be struck again. But wind, water, and life soften the edges of those blows, heal the land, and hide the worst of the story. Mars does not heal as quickly. In its loneliness, it keeps the record we cannot. And so the red planet, once feared as a god of war, now serves as a quiet historian. It sits in the dark, turning under a thin sky, while orbiters trace their glowing tracks and rovers send back pictures of broken rocks and dusty plains. Each crater, each crack, each layer of stone is a page in a book of impacts, near misses, and ancient storms. The story is not loud. It is patient and full of wonder. As you drift in this thought, floating in the silent air above Mars, the planet begins to feel less like a distant dot and more like a thoughtful neighbor, watching and remembering. Its surface is a map of every cosmic whisper that ever struck it, every messenger from deep space that chose this small world as its end. Somewhere in those scars lies a deeper pattern, a hidden message about danger and survival, written in stone and shadow. The silence deepens, and in that silence, you can almost sense another secret slowly waiting to be understood. The camera drifts in silence above a red world gone quiet. Beneath, the surface of Mars stretches out like an old, worn page. Huge circles, broken rims, and soft, shadowed basins fill the view. Some are tiny dimples in the dust. Others are vast, dark bowls so wide that mountains could fit inside them and disappear. There is no wind in your ears here. No engines. Only the slow glide of an invisible ship and the steady voice of a narrator, gentle and low. Each crater, the voice explains, is a frozen moment of violence. A rock from space once tore through this thin Martian sky, its trajectory set long ago as it drifted in orbit around the sun. In a flash, it hit the ground and carved a wound into the planet. Then the fire faded, the noise died, and time laid a soft veil of dust across the scar. Now, those scars are all that remain. They look peaceful. They feel timeless. But hidden inside them is a record of danger, a quiet warning written in stone. The camera glides lower. We pass over a crater rim that rises like a broken ring of teeth, its edges rounded by ages of tiny dust storms. The floor inside is flat and dark, lined with ripples of sand. In the center, a small hill rises an island of rock pushed upward by the shock of the impact, frozen in place like an ancient memory. Scientists on Earth stare at scenes like this through high-resolution images taken by orbiters. They use computers instead of telescopes now, eyes of glass and metal that circle Mars again and again. They count craters the way a doctor might read lines on a patient's face. Each mark tells them something about age, about risk, about what has happened, and what might happen again. On Mars, there are places almost smooth and bare, with only a few small craters scattered like freckles. There are other regions where craters overlap and crowd together, rims cutting into rims, old wounds sliced by younger ones. To a trained eye, this is not chaos. It is a pattern, a graph stretched across an entire planet. Young surfaces have fewer craters. They have not been exposed to space for long. Old surfaces are thick with them, like a desert floor after a long storm of falling stones. By comparing how many impacts appear in one area versus another, and how large they are, scientists can estimate how often big rocks and icy comets have slammed into the inner solar system. Long ago, in the early days of the planets, there was a time of heavy bombardment. Asteroids and comet fragments crashed into Mars, Earth, the Moon, and even Mercury, turning their surfaces into blazing seas of molten rock. Most of that chaos is gone now. But on Mars, the record remains. Its crust is old and mostly quiet. No oceans wash these marks away. No thick forests grow over them. Earth, by contrast, heals. Rain falls. Rivers carve new paths. Mountains rise and crumble. The crust shifts like a slow, grinding tide. Many impact craters on our own world have been erased or deeply hidden. If you only looked at Earth, you might think large impacts are rare, maybe even unlikely. But Mars does not forget so easily. Its surface is like a patient witness, still staring back at the sky that once threw stones at it. Scientists use this quiet witness as a guide. By reading the density and size of craters on Mars, they estimate how many large impactors still wander through space, crossing the orbits of the inner planets. The camera pulls back to show a chain of craters curving across the landscape, each one slightly smaller than the last. They look like footsteps. Maybe a fragmenting asteroid broke apart in the thin atmosphere, scattering shards that hit the ground one after another. To the narrator and to you listening, they become a story, a cosmic traveler, broken yet still falling, leaving a trail of scars like a sentence written in dust. Far above this silent world, in the cradle of darkness, asteroids still move. Some circle in the main belt between Mars and Jupiter. Some are kicked inward by the slow pull of gravity, their paths bent by planets, nudged by tiny pushes of sunlight. Their orbits shift, little by little, until some of them cross the path of Mars. And sometimes, the path of Earth. We do not know each rock personally. There are too many. But the craters they leave behind become a kind of census, a count of the ones that made it through. Small craters tell of pebbles and boulders that burned bright and died quickly. Huge basins with mountain-high rims speak of giant asteroids miles across, or icy comets rushing in from the dark, carrying ancient ices and dust. Some of that dust long ago came from even older places. Before there were planets, there were stars. Some of those stars ended in explosions, supernova that hurled heavy elements into space. Metals and minerals that drifted through a young nebula like ashes through air. Those grains slowly joined with others, turning into clumps, then rocks, then mountains of stone. Over time, some of those ancient travelers fell back, striking worlds like Mars and Earth, marking them with craters made from star-borne debris. The narrator's voice softens, as if speaking to someone already half in a dream. Mars, they say, is like an old diary that never burned. Each crater is an entry written by the solar system itself, notes about meteor swarms that once swept through, about clusters of impacts that might mark the passing of a shattered comet, about long quiet stretches where almost nothing large fell at all. When scientists map all these scars, they see patterns, times when big impacts were common, times when they were rare. They turn these patterns into numbers and timelines, graphs that rise and fall like slow, rocky tides. From those graphs, they estimate how often a large object might cross Earth's orbit today. Not every crossing means a hit. Space is huge, and planets are small targets. But the odds are not zero, and they never truly fade to nothing. Down on Earth, telescopes sweep the sky. Sensitive cameras look for faint moving dots of starlight changed, tiny points that shift from night to night. Spectrographs measure how light reflects from these objects, hinting at whether they are dark rock, bright ice, or something in between. Astronomers calculate their trajectories, where they came from, where they are going, and whether their paths bring them close to our world. Yet even with all this modern watching, the old craters on Mars still matter. They are the baseline, the ancient record that tells us if our picture makes sense. If today's counts of near-Earth asteroids match the story written in Martian stone, it gives scientists quiet confidence. If there is a mismatch, if the present seems strangely calm compared to the past, that raises questions. Is there something we are not seeing? Some hidden population of dark rocks? Some anomaly waiting in the glare of the sun, where our telescopes rarely look? The camera returns to a single enormous basin. Its rim is broken in places, buried under younger lava or dust. Smaller craters pockmark its floor. Inside this one crater, you can see millions of years of history layered together, like paint on an old wall. Every impact inside it changed the statistics of risk just a little. Imagine standing at the edge of that crater. The air is thin and cold. The sky is a hazy butterscotch. Above you, Phobos and Deimos Mars' tiny moons move like slow, drifting shadows. You see nothing falling. You hear nothing. Yet you are surrounded by proof that the sky is not always so quiet. This is the silent warning that Mars gives. Impacts are not just things of the past. They are part of how the solar system works. Orbits cross, paths intersect, and once in a very long while, a planet and a rock arrive at the same place at the same time. For humans, the thought can feel heavy. We are small. Our world is fragile. But in that fragility, there is also wonder and a kind of hope. Because if we can read these scars on Mars, if we can understand the timelines they trace, then we are no longer blind. We can learn which kinds of objects to watch for. We can learn how often the truly dangerous ones may appear. Mars becomes more than a distant red dot in the night. It becomes a messenger, a harbinger of what the sky is capable of. Its craters whisper to us across space. Look up. Count carefully. Know the rhythm of falling stone. The camera slowly rises, lifting away from the rugged surface. Craters shrink to tiny circles, then to faint marks, then to nothing but a subtle roughness on a rust-colored sphere. Mars turns in the soft glow of sunlight, a world shaped by fire, ice, and countless collisions. In the quiet of your room, with your eyes growing heavy, it is easy to forget that each peaceful night is part of a long, cosmic story, one written in dust and rock, in orbits and trajectories, and memories carved into distant worlds. The red planet keeps turning, keeping its diary of impacts close. And somewhere in that patient stone, in patterns still being read, a soft, hidden warning waits like a cosmic whisper at the edge of sleep, hinting that the sky has more to tell than we yet understand. In the thin light above Mars, practice looks almost like prayer. Far from Earth, where radio waves take long minutes to cross the dark, a small orbiter fires its thrusters for less than a second. The push is gentle, almost nothing at all, like a finger tapping a drifting leaf. Yet that tiny burst shifts its path hundreds of miles weeks from now. On the screen in mission control, the arc of its orbit bends by a hair's width. That hair's width is the point of the night. Engineers lean toward the soft glow of monitors. Numbers scroll, calm and endless, tracking speed, angle, and time. A voice calls out data in a room meant for focus, not drama. There is no crowd, no countdown. It is a rehearsal, a careful test of how to move a machine along a fragile path, the same kind of control that one day might be needed to nudge a real threat off a collision course with Earth. Outside, Mars turns slowly below, painted in rust and shadow. The orbiter swings around the planet like a dancer circling a partner, its path guided by gravity and the smallest of corrections. The spacecraft is not chasing a comet tonight, and there is no asteroid in sight. But the math is the same. The hands that guide it, the minds that planned it, are learning the quiet art of planetary defense. Far below, a rover hums to life. Its metal body is dusted with fine red grains. The sky above is butterscotch and thin. Slow motors turn its wheels. It crawls toward a dark rock that caught the attention of scientists back on Earth, a shard that looks out of place in the soft soil. The rover stops and unfolds its tools like a patient hand. A camera focuses. A drill lowers. A beam of light scans the stone, reading the way it reflects, the colors hidden in its surface. Years ago, in Earth laboratories, people trained these instruments to act like a spectrograph, to read the fingerprints of minerals and metals without bringing them home. Now, on this faraway world, those lessons are quietly at work. To the outside eye, it is just another Martian rock. But a deeper truth waits in the data. Someday a mission may arrive at a dark, tumbling visitor, a near-Earth asteroid, or something stranger, and we'll need to know what it is made of before anyone dares to push it. Is it a solid block, or more like a loose heap held together by its own weak gravity? You cannot shove a sandpile the way you push a stone. To move a harbinger of danger safely, you must first understand its nature. So the rover practices. It learns how to read unknown surfaces and drill without breaking itself. Every sample it takes, every strange texture it photographs, trains the people who will one day send a mission not to a quiet crater, but to a moving target that hums through space like an ancient traveler with its own secret path. Back at Mission Control, the room is dim and full of gentle machine noise. Computer fans whisper. Chairs roll softly on the floor. The work is too delicate, and the stakes, though far in the future, feel too large for anything but care. On the big screen, a stream of dots crawls in from space. Each dot is a packet of data, a tiny message that left Mars more than 10 minutes ago. There is no way to hurry it. Light itself needs that much time. So the people here have learned to live with delay. They send a command and then sit in the cradle of silence, waiting to see what their distant partners have done. This patience is its own kind of training. If a real danger ever appeared, an unexplained object with a strange orbit, or a known asteroid drifting a little too close, humanity would have to act months or years before the closest pass. There would be no last-second heroics, no sudden push at the final moment. Planetary defense is slow, quiet work that must begin long before the danger feels real. The calm of this room, the steady breath of its people, is part of the rehearsal. The teams also study the space around Mars. They watch how the solar wind moves, how charged particles flow past the planet and strip at its thin air. With barely any magnetic shield of its own, Mars stands almost naked before the sun. These measurements are more than numbers. They show the background forces any future defender would have to face. A spacecraft meant to push an asteroid must survive in that same wind. Its orbit must hold steady while the sun tugs and pulls at it with invisible fingers. The people who fly today's orbiters learn to account for all of it: the pressure of sunlight on a solar panel, the faint drag from the upper wisps of atmosphere, the tiny leaks of fuel that can twist a path over time. They peel these whispers out of the data until what is left is clear truth. To you, watching from the safety of Earth, it might seem distant and abstract, like a game of numbers. But imagine standing in that room and knowing that each line on the screen represents a skill your species did not have 100 years ago. Imagine knowing that one day, these tricks of orbit and trajectory might be all that stands between your world and a silent rock that never meant you harm. but could erase whole cities in an instant. These small motions point to a larger question. If an unexplained visitor ever appeared at the edge of our planetary system, a dark object with an odd spectrum, an anomaly that does not match any known comet or asteroid, would we be ready to meet it? Would we know how to approach without breaking it? How to touch without losing control? How to guide without tearing it apart? In the hum of machines and the soft murmur of voices, the answer is forming, slowly, test by test. Mars has become a quiet stage where humanity practices its lines and learns its marks. The planet itself watches with its ancient craters and frozen dunes, offering open sky and thin air as a testing ground. High above its surface, orbits cross like careful brushstrokes. On the ground, wheel tracks fade under drifting dust. Data flows homeward in narrow beams of starlight-powered radio. And somewhere in all this, a thought takes shape. Maybe Mars is not just a world to visit, not just a red dot for our telescopes. Maybe, in ways we are only beginning to sense, it is part of our shield. What kind of shield it might be, a place to stand and watch the sky, a harbor if Earth must one day move people away from danger, or something stranger still remains hidden for now. The rehearsal continues, quiet and patient, as if the planet and its machines know that the script is not yet complete. In the drifting quiet between signals, under the soft hiss of solar wind against thin air, it is easy to feel that Mars is holding a role it has not yet revealed. Waiting like a silent partner in a dance we are only just learning to perform. The camera glides over the rust-red world in a slow, steady drift. Below, valleys stretch like old scars, winding between jagged hills. Shadows pour into deep canyons, and at the poles, bright caps of frozen carbon dioxide and water glimmer in the soft glow of distant sunlight. Mars turns quietly beneath the black sky, a small companion to Earth. For a long time, Mars was only a point of light, a wandering star watched by ancient astronomers. Later, telescopes revealed its polar caps and dust storms. Orbiters mapped every crater and ridge, turning blurry patches into clear terrain. The planet changed in our minds, from a myth to a landscape, from a symbol to a place. Now, as the camera drifts over its surface, Mars is something else as well, a possible fortress, a fragile shelter in the vastness of space. Imagine, beneath these red plains, a hidden world, not carved by rivers or wind, but by human hands. Habitats are buried under thick blankets of regolith, the loose dust and rock that covers the surface. From above, there is almost nothing to see, only small domes, faint lights, antennas reaching upward like careful fingers. But below, in tunnels and chambers carved into rock, there is warmth, air, and quiet life. These underground cities are designed for protection. On the surface, Mars is bathed in harsh radiation. Its thin atmosphere cannot shield against high-energy particles from the sun or from deeper space. Meteorites strike more often here than on Earth. The regolith becomes a shield, a gentle veil of stone. A few meters of it can turn deadly rays into a harmless whisper, letting people sleep in safety as dust storms howl above. Inside, the light is soft and controlled. Plants grow in long rows beneath lamps that mimic sunlight. Water moves in quiet loops, cleaned and reused again and again. The air smells faintly of soil, metal, and green leaves. People work slowly, checking instruments and watching screens that show the world above. It is not the wild, open life of Earth's forests and oceans. It is closer, smaller, more careful. But there is still wonder in it, and there is hope. Outside, the planet continues its silent orbit. From here, Earth is not a huge globe filling the sky. It is a star, a tiny blue point with a soft halo of light. On clear nights, settlers might climb to the surface in pressurized rovers, drive out to a dark plateau, and stand beside their vehicle, looking up. They know that on that faint blue star are clouds, waves, and cities glowing beneath an atmosphere they can no longer breathe. For some of them, Earth is a place they remember. The sound of rain on windows, the smell of wet grass, the feel of ocean water around their legs. For others, Earth is only a story told by parents and teachers, by old recordings brought across space. Either way, it lives in their minds as a cradle of life, a home they carry in memory, even as they build a new one under Mars's surface. The idea of Mars as a fortress does not begin with fear. It begins with observation and quiet planning. Scientists on Earth study comet trajectories and asteroid orbits, tracing their paths with telescopes and spectrographs. They know that, over long stretches of time, large impacts have reshaped planets. On Earth, some of these events were harbingers of change collisions that ended eras and erased entire branches of the tree of life. The same sky that brings gentle starlight can also send an ancient traveler on a collision course. To guard against this, humans imagine not just one world, but many. They talk about backup civilizations, not as grand empires, but as small, steady communities scattered across space. Mars is the nearest step, the closest neighbor where such a community might survive if something unthinkable happened to Earth. Here, under regolith roofs and inside pressurized tunnels, people could wait out a long, dark age, keeping knowledge alive like a fragile flame. Far beyond Mars, other ideas are already taking shape. Telescopes search for exoplanets, worlds orbiting distant stars. Some of these planets lie in what scientists call the habitable zone, where temperatures might allow liquid water to exist. They are too far to reach with today's spacecraft, tiny specks detected by dim dips in starlight. Yet, in imagination, they become distant cousins to Mars, hints of a future chain of cradles. In this larger vision, Mars is the first fortress in a series of outposts. It lies close enough that signals from Earth arrive in minutes, not years. Supplies can be sent, people can travel, and problems can still be solved together. The planet is harsh, but it is knowable. Robots have crawled across its surface, sampling soil and rock. Orbiters have watched dust devils twist across dunes and peered into canyons deeper than any on Earth. And yet, even as understanding grows, Mars remains a fragile promise. Its air is thin, its water mostly locked in ice and minerals. Any settlement here must be tended carefully, like a small garden in an endless desert. Every breath, every drop of water, every scrap of food must be accounted for. A damaged airlock or a failed pump could turn safety into danger. The fortress is not a castle with high stone walls. It is more like a nest of glass and metal, delicate and precise, held together by human attention. Still, the dream persists. People picture children growing up here, running along curved corridors, chasing each other past windows that look out on a red horizon. They imagine classrooms where maps of two worlds hang side by side, and stories that mix both planets into one long memory. From orbit, the sight is striking. A spacecraft drifting above Mars might see faint clusters of light where habitats glow softly through the dust. Solar panels spread out like dark wings. Communications dishes point upward, sending narrow beams of data toward Earth and receiving whispers in return. Below, ancient craters and young outposts share the same landscape, old and new layered together in quiet contrast. If someday a large asteroid were discovered on a direct trajectory toward Earth, the people on Mars would watch from their shelters beneath the regolith. They would see simulations of impact and forecasts of smoke rising into the upper atmosphere. From their small, distant fortress, they would feel a deep ache for the planet that gave them life. They would grieve, and they would wait, holding on to the hope that some on Earth would survive. But they would also know that, even if Earth fell silent for a while, the story of humanity would not end. It would continue here, in underground farms and quiet laboratories, in journals and digital archives. Knowledge of oceans and forests, of languages and music, of science and art would survive inside these sheltering walls, resting as if asleep, ready to awaken when the time was right to venture outward again. And Mars would not be alone. Around it move smaller bodies, moons, asteroids, and fragments of rock that share its orbit. Some of these objects may one day become partners in survival, sources of water and metals, stepping stones for travel farther into space. They are small, silent companions drifting in the same sunlight, waiting to be explored. As the camera pulls slowly back, Mars shrinks in the frame, turning beneath its thin clouds and swirling dust storms. Its polar caps gleam, its canyons cut dark lines across its face. Somewhere under that surface, life hums softly in artificial light, sheltered from a harsh cosmos by a few meters of ancient dust. And all around, scattered through the darkness, lie other stones and shadows, nearby rocks that may hold their own quiet lessons for how a fragile species can endure. In the deep, drifting quiet, one might almost feel that those silent rocks are watching too, patient and unread, holding another secret that is yet to be understood. High above the rust-red deserts of Mars, two small shapes glide through the dark. They are not grand like our moon. They are not smooth or round. They look more like broken stones someone tossed into the sky and forgot. In the soft glow of distant starlight, Phobos and Deimos drift past like ancient travelers, frozen in mid-fall. They are tiny, fragile, and yet they hold lessons that may one day protect an entire world. From the surface of Mars, the scene feels quiet and slow. The thin atmosphere barely moves. Dust lies in gentle ripples, shaped by winds that come and go like a memory. Above this stillness, Phobos races across the sky, close and fast, its lumpy body throwing a drifting shadow over the plains. Deimos, smaller and farther away, moves more slowly, a faint speck that rises and sets like a wandering star. If you were lying back in the cold Martian night, you could watch them both, one hurried, one shy, crossing the dark like two different thoughts in the same mind. Phobos is the larger of the two, though large is a generous word. It is only about as wide as a small city, a jumble of rock and dust carved by craters. Its surface is scratched and scarred, like a face that has seen too many storms. Long grooves stretch across it, as if something once tried to pull it apart. Deimos is smaller still, smoother, shaped like a quiet pebble hiding in a stream. Both moons are so light that their gravity is weak. You could leap from their surface and never fall back if you pushed too hard. They are not grand worlds. They are more like pieces of something that broke away long ago. Scientists have wondered for many years where these moons came from. Some think they are captured asteroids, pulled from their original paths by Mars' gravity. In this story, they were once wanderers from the crowded belt of rocks farther out from the sun, drifting along their own lonely trajectories. Perhaps they were shaped in the same places as comets and dark, carbon-rich stones, then drawn inward, slowed, and trapped. Others imagine a different past, a giant impact that shattered a larger body near Mars and left behind a ring of debris that clumped together. Whatever their origin, Phobos and Deimos feel like visitors, as if Mars reached out and caught two messengers from the greater swarm of rocks beyond. Seen up close, their surfaces tell a quiet story. The light that touches them is thin and cool, a second-hand glow reflected from Mars and the distant sun. Craters overlap like layers of time, each impact a brief moment of violence in an otherwise endless calm. Fine dust blankets the rocks, forming slopes that slide slowly over thousands of years. There is no air to carry a sound, no wind to erase a footprint. If a spacecraft lands and leaves, its traces could remain there for ages, like a signature in a cradle of silence. Phobos and Deimos hold memories in the form of dust and stone, written in a language of craters and shadows. For humans planning to explore the solar system, these moons are more than curiosities. They are practice grounds. Their weak gravity makes them perfect places to learn how to anchor to small bodies without bouncing away. Engineers imagine harpoons, drills, and gentle thrusters working together so a ship can cling to a rock that barely holds it. These techniques are not just for exploration, they are for defense. Someday, an asteroid might be found on a dangerous trajectory toward Earth, an ancient traveler turned harbinger of disaster. If humans know how to land on such a body, how to push it, mine it, or slowly nudge it, they might change its path just enough to keep the planet safe. On Phobos, you can almost picture the training ground. A small craft settles onto the uneven surface, its legs spreading wide like careful fingers. Anchors bite into the dusty regolith. Robotic arms reach out, gripping boulders, testing how easily they move. Each motion is measured, recorded, and compared. Every slip and slide teaches something about how these tiny worlds respond to touch. In the weak gravity, even a slight push sends dust floating away in slow arcs, a gentle veil drifting off into space. It looks peaceful, almost like a dream, but the data collected there could one day mean the difference between safety and catastrophe for Earth. Deimos offers a different kind of classroom. Because it is farther from Mars and orbits more slowly, its sky would feel calmer, less hurried. A spacecraft hovering nearby could circle it with very little fuel, practicing close maneuvers around a small, irregular body. Scientists imagine setting up telescopes there, small instruments watching Mars, the Sun, and the distant stars. From this tiny moon, you could study how sunlight warms a rock and makes it spin, or how small jets of dust might change its motion over time. These are subtle forces, like cosmic whispers, but over years, they can shift an asteroid's trajectory by thousands of miles. Understanding these hidden pushes and pulls is part of the art of planetary defense. To reach these moons in the first place, humans had to learn how to travel with great care. Spacecraft navigate using gravity, timing, and tiny bursts of fuel, adjusting their paths like dancers following a pattern only they can see. They follow orbits carefully calculated from the pull of Mars, the Sun, and the moons themselves. Each mission is a test of our ability to move through the solar system with precision. The same skills that guide a probe softly onto Phobos are the skills that could guide a deflection mission to an asteroid passing near Earth. In this way, every visit to these small moons is also a rehearsal, a quiet, deliberate practice for a future that has not yet arrived. From a distance, Phobos and Deimos look like anomalies, misshapen, dark, almost forgotten. They are easy to overlook when compared to the bright rings of Saturn or the swirling storms of Jupiter. Yet, in their shadows, there is something important. They show us that not every world needs to be large to matter. Sometimes the smallest stones hold the biggest lessons. Around them, the starlight feels older, the silence deeper, as if the universe is pausing to see what we will do with this chance to learn. As the night over Mars stretches on, the two moons continue their endless circuits. Phobos sweeps by, casting its drifting shadow over red canyons and dry riverbeds, then slips back into the dark. Deimos follows its slower path, rising like a distant lantern and sinking again beyond the horizon. Their orbits repeat, again and again, a calm pattern written against the backdrop of the stars. Beyond them, farther from the Sun, lies a crowded region filled with countless other rocks-bigger asteroids, darker fragments, and hidden travelers that have never been named. Some move alone, some in families, some following paths that only careful telescopes and spectrographs can trace. In the quiet presence of Phobos and Deimos, the mind drifts outward toward that unseen swarm, wondering what secret patterns might be waiting there, just beyond the reach of Mars, in a darkness that is not empty at all. And as that thought hangs in the thin Martian air, the silence deepens. carrying with it the gentle sense that somewhere out there, among the drifting stones, another mystery is slowly turning toward the light. You drift outward, past the rusty glow of Mars, into a wide and quiet region between worlds. The sun is smaller here, a soft lantern hanging far away, wrapping everything in a pale golden haze. This is the asteroid belt, a crowded ring of stone and metal circling the sun in a patient, endless loop. The camera glides beside a lonely rock, only a few hundred meters across. Its surface is pitted with craters, coated in dust that has not been touched in billions of years. As it turns, its rough edges catch the sunlight and flare for a moment, then sink back into shadow. Around it, countless other bodies move on their own paths. In the distance, Mars hangs like a dim red coin, close to the inner edge of this vast belt. It is not in the belt itself, but it watches from nearby, a quiet witness to the traffic of ancient stones. Its weak gravity adds a small tug here, a tilt there, changing the rhythm of orbits over ages. These tiny pulls, along with the deeper pull of Jupiter farther out, shape the whole region like invisible fingers molding clay. The narrator's voice stays soft, almost like a whisper in a dark theater. The asteroid belt is not a solid wall of rocks, they explain. It is mostly empty space. If you stood on one asteroid, you might not see another with your own eyes at all. Yet on the scale of the solar system, this region is crowded. Millions of bodies drift here, each one following a path it has held for a very long time. We watch one of those paths now. The shot locks onto a coal-black object, a fragment of an old comet, frozen and scarred. Its orbit is not like the others. While most asteroids move in smooth, gentle ellipses, this fragment cuts across the belt at a steeper angle, like a messenger taking a shortcut through a sleeping crowd. As it passes through thin veils of dust and gas, a faint halo forms around it, lit by the distant sun. On the screen, thin lines appear, tracing the motion of objects around us. Orbits unfold like chalk circles drawn across the dark. Some are nearly perfect loops. Others are stretched, with long, narrow curves that carry them closer to the sun and then fling them far back out. The narrator names the closest point in those long paths, perihelion, a quiet word for a dramatic moment, when a traveler swings past the sun, bathed in light and heat, before returning to the cold outer reaches. The animation slows until all the orbits look almost still, like a painting. You can imagine them as brushstrokes across the sky, each line a memory of motion. For a moment, time seems to stop. But underneath this calm picture, the laws of gravity continue to work. Every orbit is changing, even if only by a hair's breadth. A distant nudge from Jupiter. Each event writes a tiny note into the long song of the belt. From Mars, the view of this region is very different than from Earth. The documentary pulls back, showing both planets on opposite sides of the belt, like two observers standing at the edges of a crowd. Earth watches from the inner solar system, looking outward through the haze. Mars sits closer, peering sideways into the ring of stone. With two sets of eyes, we can see depth and detail that one world alone might miss. The scene shifts to a future Mars, quiet but busy with human tools. On a ridge high above a dusty plain, a row of telescopes points toward the belt. Their metal frames are frosted with fine red dust, their mirrors silver and still. Inside, spectrographs rest in cool dark rooms, splitting faint starlight into thin colored lines. Every photon that reaches them carries a story. What it passed, what it reflected from, what it was scattered by on its way. Because Mars has a thinner atmosphere and fewer clouds, its skies are often clearer than Earth's. Telescopes here can watch the belt with steady patience, night after. Martian night. They measure small changes in brightness as asteroids occult distant stars, passing in front of them for just a heartbeat. They track faint smudges of light that could be comet fragments or dust trails. They follow the slow shift of each object's trajectory as it responds to gravity and sunlight. Over time, patterns begin to appear in the data. Some objects spiral inward, their orbits shrinking by tiny steps as they lose energy. A few start to cross paths with the inner planets, becoming near-Earth asteroids. Others grow more restless after gentle pushes, like nudges from the thermal force of sunlight warming their surfaces. Still others behave in ways that do not quite match the models. These are flagged as anomalies, strange cases that ask for a closer look. From Earth, those anomalies might look like simple dots that jump slightly from one night to the next. From Mars, seen at a different angle, their paths reveal extra detail. Maybe a curve where Earth saw only a straight line. Maybe a twist hidden behind the glare of the sun. With this double view, astronomers can build a more complete 3D picture of each orbit, almost like tracing the path of a drifting leaf by watching it from two sides of a river. The narrator invites you to imagine the kinds of visitors that might pass through this crowded belt. Some are simple chunks of rock, pulled in from the outer dark by gravity alone. Others are ancient travelers, comets that have been circling the sun since long before humans looked up and wondered. And some may come from far beyond our solar system, interstellar objects on long, lonely journeys between stars. When they slip through the belt, they leave small fingerprints in the motions of nearby stones. Mars-based telescopes, working together with observatories on Earth, could be the first to spot those fingerprints. Their computers search for forbidden patterns in the data, paths that do not match the usual families of asteroids and comets. A sudden tilt in an orbit, a speed that seems too fast for the sun's pull alone, a trajectory that brushes through the belt once and never returns. Each one is a quiet signal, a possible harbinger from the wider galaxy. The film stays gentle. There are no alarms, no flashing warnings, only the slow unfolding of orbits and the soft hum of background music. Yet the idea settles in your mind. Between Mars and Jupiter, this broad ring of debris is not just clutter. It is a listening field, a place where stones and dust record the passage of every visitor. Their positions, their slight changes in speed, even their tilts and wobbles, all become part of a hidden logbook written in motion. As the chapter draws towards silence, the camera returns to a single asteroid. It turns slowly, half in shadow, half in the sun's thin light. In the distance, you can just see the small red star of Mars and the faint blue glow of Earth, two worlds watching from opposite sides. Between them, the belt keeps its quiet dance. Somewhere among these drifting shapes, an unexpected visitor may already be passing, leaving behind a trail of subtle changes that our instruments are only beginning to notice. You feel the weight of the quiet, the thin dust, the slow spin of stone. The belt seems peaceful, almost like a cradle of silence between worlds. But carried inside that silence are questions. What else moves here that we have not yet seen? What messages are written in these shifting trajectories and tiny anomalies? The glow fades, the orbits dim, and in the gentle dark between Mars and Earth, one could almost sense that something unseen is still moving, waiting for its story to be understood. The night sky looks calm from Earth, a soft, dark ocean of stars. But sometimes, hidden in that darkness, something moves in a way that does not belong. Not a usual comet, not a familiar asteroid, but a stranger from far away. An interstellar traveler, slipping through our solar system like a quiet, cosmic whisper. These visitors do not circle our sun the way planets do. They come in on sharp, slanting paths, like stones skipping across a pond. Their orbits are open curves, not gentle loops. They rush in from the deep between stars, curve once around the sun, and then drift back out into the dark again, never to return. They are not from here. On Earth, Telescopes notice them first as tiny points of light. At first, they look like distant, normal rocks. Then, scientists begin to trace their paths, measuring how fast they move and how their trajectory bends in the sun's gravity. The math whispers a surprise. This path does not match a normal solar system orbit. This object came from far beyond the edge of our home star's family. Sometimes their motion holds another quiet mystery. An object speeds up or slows down just a little more than gravity alone can explain. It is like watching a leaf on a river that suddenly drifts sideways as if nudged by an invisible hand. On our graphs and in our equations, those small changes become anomalies, unexplained accelerations that tease the mind. Nothing explodes, nothing flashes, but the question hangs in the air. What exactly are we seeing? Most likely, these travelers are only lonely pieces of rock and ice, broken fragments thrown out of other star systems long ago. They wander for millions, even billions of years between suns, frozen and silent. Yet, because they come from somewhere else, they carry stories written in their atoms, stories about other skies, other worlds, other disasters and creations. When one passes through our solar system, it is as if a message in a bottle is washed into our cosmic shore. On Earth, we do our best to read those messages. We turn the largest telescopes toward them, tracking every flicker of reflected sunlight. We use spectrographs to split that light into colors, like passing it through a crystal prism. In those thin lines of color, we can read what elements the visitor is made of: carbon, oxygen, metals from dead stars, frozen gas from long-vanished clouds. Each line is a clue, each curve a piece of a very old memory. But there is a limit to what one planet can see. From Earth alone, the path of an interstellar object can look like a single thin line drawn against the sky. Measurements are precise, but they are still taken from just one place in space. It is like listening to a distant whisper with only one ear. You can tell that something is there, but you cannot always tell exactly where it came from or where it is truly going. Now imagine adding a second ear. Mars, moving along its own orbit, circles the sun with a different rhythm and at a different distance. At times, it sits on the other side of the solar system from Earth, offering a completely new angle on the same visitor. From Mars, that same interstellar rock would cut a slightly different path against the stars. Together, these two views, Earth and Mars, could turn a thin line into a rich, three-dimensional trail. In the quiet observatories of Mars, the night would look different. The sky would be a darker ocean, with stars unblurred by thick air. Dust might drift in the thin Martian breeze outside, but above, the starlight would be sharp, almost painfully clear. A telescope on Mars could watch the same strange traveler we see from Earth, but from a shifted position, like a second eye opened wider into the dark. With that second eye, we could triangulate, tracing the visitor's true path through space with far greater detail. Spectrographs on Mars could also listen to the visitor's light. The same object, viewed from a different angle, might reveal features hidden from Earth: a faint tail of gas, a jet of dust, a tiny spin. Even small differences in timing, when the object brightens or fades as it spins, could help us map its shape, its rotation, its scars. A crack on one side, a patch of darker rock on another, a plume of gas escaping from a hidden pocket of ice. Two planets watching together could turn a distant point of light into a real, textured world. With Earth and Mars working side by side, the solar system becomes a linked observatory. Data flows between worlds, images, spectra, careful tables of time and brightness. Computers on both. Planets would weave the numbers together, drawing a precise orbit through three-dimensional space. That orbit tells us where the visitor came from and how long it has been wandering. It might even hint at the kind of region it passed through: a thick cloud of dust, the edge of a distant nebula, or the crowded inner lanes of another star's planetary system. Most of these interstellar objects are likely harmless. They do not aim for planets on purpose. They simply follow the curves of gravity. They glide past us, cold and uninterested, like driftwood passing a ship in the night. But some paths come closer, and that closeness makes us pay attention. It raises a soft, uneasy thought. Could one of these visitors ever be a warning, a subtle omen written in rock and ice? If a large interstellar object were on a path that crossed Earth's orbit, we would want to know as early as possible. Not in fear, but in respect for the power of impacts, for the thin, fragile layer of air and ocean that keeps life safe. Earth's telescopes can already scan the skies for near-Earth objects. But with Mars helping, we could see farther, refine the orbits faster, and understand the risk with more calm and clarity. The two planets together would act like twin guardians, quietly watching the cosmic traffic that drifts through our region of space. In this way, the sky truly becomes a dark ocean. Asteroids are small islands, comets are icy ships with glowing tails, and interstellar visitors are foreign boats that appear suddenly on the horizon. Some sail by without ever knowing we are here. Others pass close enough that their wake ripples across our measurements, tugging on our curiosity, stirring old fears of falling stars and sudden fire. Yet even those fears carry a strange kind of wonder. We are small, but we are watching. As you lie back and imagine this ocean above, you might picture lonely rocks gliding under starlight, casting faint, slow-moving shadows across the invisible plains of the solar system. You might see Earth and Mars as two quiet listening posts, each wrapped in its own thin shell of atmosphere and dust, each raising metal mirrors toward the night. They do not shout into space. They simply listen, measure, and wait. In that patient waiting, the universe begins to reveal its patterns, the rhythm of orbits, the drift of travelers, the soft trace of things that almost, but not quite, cross our path. And still, behind these calm measurements, a deeper question lingers. If interstellar messengers are already passing through our skies, what else have they seen? Have they crossed star systems where planets were torn apart, where oceans boiled away, where civilizations rose and fell under sudden storms of rock and fire? Do the scars on these travelers match the scars we find in Earth's own record layers of ash? Craters filled with water, shattered fossils of worlds that almost ended. And somewhere in the dust and stone of Mars, are there silent marks of its own disasters, waiting to speak the same language of loss and survival? The sky above remains quiet, a cradle of silence laid over the world. Interstellar strangers come and go, leaving thin, bright signatures in our data and soft ripples in our thoughts. Their presence is gentle, almost easy to miss, yet filled with meaning we have only begun to understand. As you drift towards sleep, the dark ocean of space seems to lean closer, as if sharing a secret it cannot yet fully say. In that drifting quiet, one could almost feel that hidden in every passing rock and every ancient scar is a clue to something larger, something waiting, patient, and unspoken. Just beyond the edge of our knowing, the screen opens on a slow drifting Earth, wrapped in a soft glow. Music moves like a gentle veil. The narrator speaks in a calm, steady tone, as if telling an old story by starlight. Tonight, the story is not just about life, but about the times when life almost ended, the echoes of extinction. We glide backward through time. Forests appear and vanish like passing dreams. Seas shrink and grow. Far below, dinosaurs walk under warm skies, unaware of the ancient traveler that has already begun its long, silent fall toward them. In the darkness of space, a single rock circles the sun on a fragile trajectory. It is one comet or asteroid among many, a small messenger of stone and ice. For millions of years it drifts unnoticed. Then gravity changes its path. Like a harbinger, it turns toward Earth. The picture slows. The rock grows in the frame. You can almost feel the air shiver as it rushes in, faster than any sound. When it hits, the world flashes white. A shock wave circles the planet. Dust climbs high into the sky, forming a thick, choking cloud that wraps the Earth in darkness. Sunlight weakens. Temperatures fall. The gentle rhythm of life, once steady for millions of years, stumbles. Many of the dinosaurs vanish. Whole forests, whole oceans of tiny creatures disappear from the story. But high above, the planet keeps on turning calm and indifferent, like a slow blue marble in space. The dust settles grain by grain. New plants sprout where the old ones fell. Small animals creep out of their hiding places. Life bends, but it does not break. The echo of extinction fades into a new kind of song. The narrator's voice softens. This was not the only time. Deep under our feet, in rock layers that act like pages in a book, scientists have found other scars. Long before dinosaurs, strange sea creatures ruled the world, and whole ages ended in silence we still do not fully understand. Some of these endings may have come from above, from impacts lost to time. Others were born within the planet itself. Giant volcanoes once poured lava across continents, filled the air with gas and ash, and swung the climate wildly. Again and again, life walked to the edge of a cliff. The film drifts out into space, leaving Earth behind. Ahead, a small red world appears, Mars. It hangs like a quiet ember in the dark, its surface cold and still. Where Earth healed its wounds with wind, rain, and oceans, Mars stayed frozen in place. Its silence preserved what our planet erased. We sweep over Martian deserts, past ancient craters that overlap like rings on an old tree. Each crater is a fossil impact, a circle in stone marking the moment a rock from space met a world. Some are small, almost gentle dimples. Others are wide basins, the size of countries, where the crust itself once shook and cracked. On Earth, many such craters were worn away long ago. Plate tectonics folded them. Rivers softened their edges. Forest roots dug into their walls. But on Mars the air is thin, the weather is light, and time moves differently. Here, an impact can remain almost unchanged for billions of years, a quiet record of an ancient blow. Scientists send spacecraft to orbit Mars, cameras pointed down like careful eyes. From those orbits, they read the craters the way you might read the rings of a tree. By counting them, by measuring their size and depth, they can ask a simple but deep question. How often does doom arrive? If Mars is covered in old scars and Earth is not, that does not mean our world was spared. It means our world healed in a different way. Mars, with its frozen plains and rusted hills, keeps a clearer memory. It holds on to every bruise and every fracture, like a diary left open on the table of the solar system. The camera drifts lower, finding not just craters, but mountains. On the horizon rises Olympus Mons, the tallest volcano known in the solar system. It is not active now, but once, long ago, it poured rivers of lava across the Martian surface. Other volcanoes, spread across great plateaus, did the same. On Earth, volcanoes have played a double role. They can darken skies with ash and chill the world. Yet over long times, they help build atmospheres, warming planets, and keeping oceans from freezing. The same forces that bring crisis can also make life possible. On Mars, the story seems to have stopped midway. The channels of long-gone rivers still line the land, curving and twisting like memories of motion. Dry basins hint at ancient lakes and maybe even oceans. Once, water flowed there. Once, Angara. Softer sky, Mars may have felt almost Earth-like. Now those rivers are only shapes in the dust, traced by rovers and watched by orbiting telescopes. They are witnesses that cannot speak, but their silence still carries meaning. When scientists map these channels and study the minerals inside them, they are listening for a cosmic whisper. Did extinction come to Mars too? Did something end a chance at life before it fully began? Back on Earth, geologists split open rocks with careful hands. Inside, they find thin layers rich in rare metals that come from space, tiny glass beads formed in ancient fire, and sudden changes in fossil patterns. These are the fingerprints of disaster. With drills, spectrographs, and microscopes, they piece together old nights of chaos from grains of sand and dust. Astronomers add their own clues. They point telescopes toward nearby stars and search for the fading marks of ancient supernova, giant explosions that once lit the sky. Some of those blasts may have washed Earth in radiation, quietly shifting the chemistry of air and ocean. Together, these traces, craters, ash, buried metals, faint starlight, form a single pattern. The universe is not only gentle and calm, it also sends sudden shocks and strange anomalies. Yet between those blows, life keeps returning, turning loss into a quiet, enduring resilience. We see plants creeping over a once barren slope, coral reefs rebuilding where old reefs fell, animals adapting in new shapes and colors. Extinction redraws the map, and life colors it in again. Resilience becomes one of Earth's deepest memories. As you listen in the dark or in the soft glow before sleep, you might feel a quiet awe. Our species is young, yet we are already building tools to listen and to watch. We track asteroid trajectories with patient surveys and place eyes in orbit to watch the sky, catching small messengers of stone long before they reach us. We send robots to Mars to read its frozen memories and compare them with our own, learning how often worlds are challenged and how often they endure, here and on distant exoplanets. In this work, there is both fear and hope. Fear, because we now know how fragile our world can be when the universe turns its face toward us. Hope, because for the first time, a living species has the chance to see these threats coming and to answer them. We are learning to turn random fate into something we can measure, predict, and maybe one day guide. The music softens again. Earth and Mars drift side by side on the screen, two small worlds in a wide, dark sea. One is blue and alive, still changing, still singing its many-layered song. The other is red and quiet, a cradle of silence holding the echoes of what might have been. Between them lies a question that hums like a low note beneath the score. How many times has doom arrived, and how many times has life faced it and gone on? No one knows for sure. The answers are scattered in craters, in rock layers, in distant starlight. For now, we listen. We measure. We dream of better shields and wider eyes on the sky. And in the drifting quiet between impacts, under the gentle veil of our atmosphere, one could almost sense that something unseen is still watching, still waiting to be understood, high above the turning Earth. Where blue thins into a gentle veil and fades to black, a web of quiet machines keeps watch. They drift in patient orbit, small bodies gliding through the cradle of silence. Cities glow far below, oceans hold a soft shimmer of starlight. But up here it is mostly darkness and the steady hum of instruments listening to the sky. The night looks calm. The machines know it is busy. Each satellite is tiny compared with the world it circles, yet together they make something larger than any one machine. They form a fragile ring of eyes and ears stretched around the planet. Some look inward, measuring the solar wind that washes over Earth. Others look outward, following faint specks that might be asteroids, comets, or hidden fragments, ancient travelers crossing the inner solar system. They share what they see as streams of numbers. Higher orbits carry telescopes and deep space spectrographs. Their mirrors open like calm eyes, catching rays of starlight that began their journey long before this moment. One telescope tracks a pulsar, a spinning remnant of a dead star. Its pulse is a distant cosmic whisper ticking like a clock. Another watches the sun's shifting surface, while solar wind monitors float between Earth and Sun, reading the invisible stream that can disturb the space around our planet. Farther away still, machines circle Mars. In the thin, cold air of the red world, orbiters glide over ancient valleys and dried riverbeds, their instruments pointed both downward and outward. But they also watch the same sky Earth does. From Mars, the constellations shift, yet the wandering rocks, drifting comets, and unexplained flashes belong to the same shared story. All of these watchers, near and far, are linked into one network. Radio dishes on Earth receive their signals as tiny flickers in great metal bowls. Fiber optic cables carry those signals under oceans and across continents into quiet rooms filled with screens. There, data from Earth orbit and Mars orbit merge into a single flow, like two rivers joining into one slow, steady current. Together, they trace the motion of anything that moves through the inner solar system. To the people working with this data, the sky is not just beautiful. It is full of moving pieces. Every object has a path, a trajectory that can be mapped. Computers turn points of light into orbits. If an asteroid is seen here tonight, where will it be next month? Next year? Will it slip past unnoticed, or will its line cross the orbit of Earth or Mars? Imagine drawing a dot on a page every second as something moves. If each new dot is the same distance from the last, you get a straight line. If the spacing changes, the line curves. Now imagine that line wrapping around the sun. By watching how it bends, scientists tell whether an object is trapped in a safe, repeating orbit, or whether it is a roaming messenger, just passing through. Each new measurement sharpens the line, turning a guess into a clear path. Sometimes the path shifts. A tiny pull from a planet's gravity, a small shove from sunlight, even a puff of gas from inside a comet can bend the trajectory. On the page, the change looks small. But when projected years into the future, that small bend might bring a drifting shadow closer to a planet. The network of satellites, telescopes, and spectrographs is built to notice those early bends before they grow into a harbinger of danger. In control centers lit by a soft glow, models run like slow, steady heartbeats. They take in new measurements and redraw orbits, curve by curve. If a path begins to tilt in a worrying way, no sirens blare. Instead, a quiet message appears. A report is filed. A team of specialists begins to watch more closely. This is not a fortress of walls or shields. It is a fortress of awareness. Now imagine this watch extended fully to Mars, a future ring of Martian satellites. Solar wind monitors and deep space spectrographs joins Earth's network like another set of calm eyes in the dark. Narrow radio beams connect world to world, carrying alerts across millions of miles. When a faint new dot appears against the stars, an anomaly, a possible messenger from the outer dark, the alert does not belong to one planet alone. It moves through the shared web, Earth and Mars listening together. In your mind, see a single beacon on Mars, standing lonely on a dusty ridge. The tower is modest, no taller than a small building. Above it sits a bright eye that blinks in a slow, steady rhythm. Around it, the Martian night is still. Above, the sky is black and sharp with starlight. Each blink of that beacon means data is flowing, that the network is alive, that two worlds are awake together in the dark. For someone lying in bed on Earth, listening as they drift towards sleep, it is quietly comforting to know such a watch could exist. Beyond the window, past the clouds and the atmosphere, machines simply measure and remember, they do not fear or dream. They trace the paths of ancient travelers, update the map of near space, and store a patient memory of everything that comes close to the sun. If we can see danger earlier, everything changes. A rock discovered late leaves little room for choice. At best, we step aside at the last possible moment. But a rock found decades in advance is different. With time, we can test gentle pushes, tiny nudges that shift an orbit by a fraction. A small change, made early, can turn a future impact into a distant, harmless passing. The network becomes not only an alarm, but a tool for shaping outcomes. With this awareness comes hope and responsibility. If humans live on both Earth and Mars, the choices made to protect one world will touch the other. An object steered away from Earth might pass closer to Mars, or the other way around. The networks of Vigil will have to treat both worlds as equally fragile, equally precious. Slowly, the idea of home stretches from one blue planet to two bright points in space, linked by lines of light and shared watchfulness. As the night deepens, the system keeps working. Data pulses along invisible paths, crossing space to receivers on far-off worlds. Screens glow softly in darkened rooms. Somewhere, a new object appears in the logs, just one more entry among many. For now, it is simply noted and watched, folded into the great quiet memory of the sky. In that steady watching, the universe grows a little less unknown. Each measurement peels away a layer of uncertainty, turning fear into understanding and danger into a problem that calm minds can face. And as you rest in your own small corner of this vast system, you might picture those distant machines moving through the dark, their beacons blinking with gentle purpose. The glow of their signals, the soft whisper of their data, drift through the cosmic night, hinting that somewhere just beyond our current reach, new choices and new dreams are already beginning to take shape. High above the quiet Earth, Mars hangs in the dark like a small rust-red lantern. It is not just another planet on a cold orbit. In this story, Mars becomes something else. A practice room for survival. A first step on a long staircase that leads beyond the sun. Engines roar only once in this chapter, at the beginning of a journey. After that, everything is stillness. A ship coasts along its trajectory, a silver seed drifting through the cradle of silence between worlds. Inside, people float in soft light, already learning what it means to live away from the blue glow of home. When they land, Mars does not welcome them with open arms. There is no air they can breathe, no liquid water under a gentle sky, no forests hiding under a thin pink veil of clouds. The atmosphere is so light it might as well be a ghost. The ground is sharp dust and stone. Radiation from the sun and from deep space falls across the surface like an unseen drizzle. So humans bring their own world with them. Domes rise from the red plain, round and pale under a whisper of stars. Some are full of machinery tanks, pumps, humming filters. Others glow with a soft green, lit from within like lanterns. These are the gardens, long rows of plants growing under artificial day, their roots bathing in nutrient-rich water instead of soil. Here, breathing is not something people can forget about. Every breath is a small promise kept by a network of pipes and filters. Machines clean the air, recycling exhaled carbon dioxide into oxygen again. Water is caught, cleaned, and used over and over. Steam from showers, drops from plants, thin frost scraped from outside and melted for drinking. On Mars, every molecule is counted, and nothing is truly thrown away. Gravity, too, is different. On Mars, people are lighter, about 1/3 of their Earth weight. Steps feel bouncy. Heavy loads that would bend the back at home can be lifted almost easily here. But muscles slowly shrink, and bones might weaken. So every morning, settlers walk on treadmills or pedal on bikes, held down with straps, training their bodies to stay strong in this gentler pull. Above them, the sky is not blue, but a soft, dusty brown by day. At sunset, the colors reverse. The land turns dark and the sky near the sun glows with a strange, cool blue. At night, The stars are fierce and sharp, and one of those points of light is Earth-tiny, distant, and fragile. Back on that tiny point, giant eyes search the universe. On mountaintops and in orbit, telescopes stare into the deep dark. Some collect visible starlight, others capture invisible waves from radio to infrared. They use instruments called spectrographs to spread that light into rainbows of thin lines and bands. In those patterns, scientists look for hints of gases like oxygen, methane, and water vapor, signs that a distant exoplanet might be friendly to life. Sometimes a telescope watches a star for years, measuring its brightness with perfect calm. When a planet passes in front of its star, the starlight dips just a little. It is like an exoplanet whispering, "I'm here," by casting a tiny drifting shadow across the sensor. From these small dimmings, scientists can tell how big the planet is, how long it takes to orbit, and sometimes even whether it might have clouds or oceans. We already know thousands of these worlds. Broiling hot Jupiters that skim close to their suns, frozen giants on the edge of darkness. Rocky planets in gentle orbits inside the habitable zone, where liquid water could exist. Some of these are marked as special prime candidates. They orbit calm stars, sit at just the right distance, and show hints of an atmosphere in their starlight signature. But even if one of those exoplanets is perfect, it is very, very far away. Traveling there with today's rockets would take longer than human lifetimes, longer than the memory of a single city, maybe longer than a civilization itself. So humanity starts with Mars, the closest, hardest classroom we can reach. On this red world, settlers practice everything they would need for a true journey into the deep. They build closed-loop life support systems that waste almost nothing. They grow food without sunlight, using LEDs that shine in careful colors, feeding plants exactly the light they need. They learn how to repair things without fresh supplies. If a pump breaks in the night, there is no store, no quick delivery. There is only the workshop, the spare parts, and the quiet ticking of the air monitor on the wall. They also learn trust in each other and in machines. Outside, space is only a few centimeters away, beyond thin layers of metal, plastic, and glass. Inside, the hum of fans and the gentle rush of air through vents become a kind of lullaby. You can almost imagine lying there, eyes closed, listening to that steady sound as you drift toward sleep, knowing that if it stops, the world around you would change in seconds. This is life on a training world. But it is also something else, a rehearsal for disaster. The universe is beautiful, but it is not safe. In the darkness beyond our sun, countless asteroids and comets move along their silent paths. Many are harmless ancient travelers, looping for ages along stable orbits. Yet some are harbingers of change. A slight nudge, an unexplained anomaly in their path, could send one inward toward the inner planets. Earth's history is written with these impacts. Long ago, a massive asteroid struck and helped end the age of the dinosaurs. Dust and smoke wrapped the planet in a gentle, deadly veil, blocking sunlight. Temperatures fell. Life changed. Today, telescopes scan the sky for such threats. Surveys map the trajectories of near-Earth objects, plotting their orbits, checking for future collisions. Most have no danger at all. But the work goes on, because even a small rock, moving at cosmic speed, carries enough energy to change a world. There are other risks too. A star can die in a supernova, flaring into a brief, terrible brightness. If one went off close enough, its radiation could wash over Earth's atmosphere, stripping layers, changing climate, and lighting the sky with strange colors. The odds are low, but not zero. In the language of risk, they are like a quiet whisper at the back of the mind. So scientists and dreamers ask a hard question. What if something happened to Earth? What if, in a far future century, A black swarm of asteroids was discovered on a slow, unstoppable collision course. What if a distant supernova, a hidden threat in the Milky Way, lined up just wrong with our fragile planet? In those imagined futures, Mars becomes more than a science project. It becomes an escape route. You can picture the scene in your mind. A message arrives on Mars, traveling across the void at the speed of light. It takes between 3 and 20 minutes to cross the space between the worlds, depending on where they are in their orbits. The settlers hear the news seconds after the data lands. Earth is in danger. Maybe not today, maybe not tomorrow, but within their children's lifetimes. They cannot rush back to help. Distances are too great. Launch windows are rare and costly. Instead, they do the only thing they can do. They work to preserve memory. In domes and underground vaults, they record languages, music, stories, scientific knowledge, art. They keep seeds and DNA samples. They store maps of Earth's oceans, forests, cities, and the faces of billions of people who once looked up at the sky and wondered if anyone was out there. On shelves and in data drives, the story of humanity waits. The settlers themselves are part of that story. Children born under lower gravity learn to walk in weaker pull, their bones shaped by a different world. To them, Earth is both home and legend, a bright dot in the sky their parents dream about. They grow up in luminous greenhouses and metal corridors, surrounded by the soft hiss of recycled air. Yet they carry oceans and rainstorms in their imagination. If a true planetary emergency ever comes, these Mars communities may be the ones who carry us forward. They might be the bridge between a past that began in African savannas and a future that unfolds among exoplanets orbiting distant suns. From their domes, they may one day launch missions not back to Earth, but outward, into the deeper dark, toward those small dimmings of starlight that hint at other homes. In that far-off time, engineers and navigators will use what Mars taught them: how to live in closed systems, how to protect against radiation, how to keep hope alive when everything outside is a drifting shadow and a frozen plain. Their ships will cross between stars, guided by spectrographs and radio beacons, chasing worlds that were once only data points on a screen. But tonight, the training ground is quiet. On the red desert, a single figure might stand inside a transparent dome, looking up. The sky is a deep, endless black, full of sharp points of light. Some of those stars may already hold planets with seas and clouds. One of those stars is the sun, wrapped in a faint aureole of starlight, and near it is the tiny blue-white spark of Earth. The person in the dome breathes slow, recycled air. Around them, machines hum and lights blink. Far away, telescopes keep watching, doing their patient work, scanning for both danger and promise. Escape routes and exoplanet dreams, woven together into one long plan for survival. And as the Martian night stretches on, there is a gentle, unspoken question hanging in the thin air. If all of this is the rehearsal, if Mars is the classroom and the universe the exam, what will it truly feel like on the day when the alarms finally sound, and which world will answer first? It begins with a small change in a stream of numbers. Far from any window, in a quiet control room on Earth, a computer finishes its nightly sweep of the sky. It has compared thousands of points of light, looking for motion, like a careful watcher tracing fireflies in a dark field. On the screen, one tiny dot does not move like the rest. Its path is just a little too curved, a little too strange. The system flags it. A soft chime sounds. A human looks up. There is no alarm, no shouting, only the soft hum of air vents and the gentle tapping of keys. A researcher leans closer to the display, the glow of the monitor outlining a tired but curious face. They rewind the data, frame by frame. The dot moves again, sliding across the digital stars with a slow, deliberate drift. Somewhere above, the real object is still out there, gliding through the dark. Messages travel across fiber optic cables and radio links. The dot is given a code, a first estimate of its orbit, and a question mark. The system does not yet know what it is: asteroid, comet, or something in between. It is simply labeled an anomaly, an unknown traveler entering the story of the inner solar system. On Mars, the night side faces this same sky from a different angle. High above the red planet, Mars orbiters make their steady paths. Their cameras and instruments are tuned for many tasks: mapping canyons, tracking dust storms, watching the thin, pale clouds that sometimes form over volcanoes. But they can also look out, away from Mars, into deeper space. Tonight, a request reaches them from Earth. Track this object. Watch this motion. Help us see. The orbiters obey without drama. Their long, slender bodies turn with patient grace. They lock onto a patch of sky and begin to scan, pixel by pixel, frame by frame. From Mars, the geometry is different. The same traveler appears at a slightly shifted angle, like a bird seen from another hilltop. On both planets, telescopes wake. On Earth, giant mirrors tilt in the dark. Domes open like sleepy eyes, letting in the cold air and the faint starlight. On Mars, smaller, sharper instruments, protected under domes of dust-stained glass, do the same. Motors whir. Sensors cool to deep, quiet temperatures where noise falls away and only true signals remain. The object brightens, ever so slightly, as it moves closer to the sun. A thin veil of gas and dust begins to stream from its surface. Under starlight, this faint tail is almost invisible. Under the eye of a spectrograph, it becomes a story. Lines of carbon, oxygen, and other elements, glowing softly in the dark. Now they know it is some kind of comet or a cousin of one. An icy fragment, an ancient traveler from the cold, outer reaches. Around the world and around Mars, data starts to flow. In Earth's control centers, in Martian outposts, and in orbiting stations circling both worlds, streams of numbers move through screens and servers. They are brightness readings, position measurements, color details from the spectrographs. Each line is like a tiny whisper from the unknown traveler. Computers turn these whispers into patterns. Programs trace the object's orbit, adjusting it with each new observation. Tiny changes in location reshape the future path. The models run again and again, like waves washing over sand, smoothing the curve of prediction. The scientists are not frantic. They are focused. You can almost see them if you close your eyes. People in soft chairs, hands around warm mugs, staring at gentle graphs that climb and fall in quiet colors. Some are on Earth, where the sky in their window is blue or full of clouds. Some are on Mars, where the window might show a copper horizon and a thin line of dust. All of them share the same thing: a growing sense of wonder and a fragile concern. The question they ask is simple: how close will this traveler come? To answer, they use models. The word might sound cold, but the work is almost tender. They feed the computers every known detail: the mass of the Sun, the pull of Jupiter, the tug of Mars, the subtle drag from sunlight itself. They add small unknowns, like the jets of gas that may burst from the comet's surface as it warms. These jets can push and twist the object in small ways, like tiny thrusters on a drifting ship. The computers turn these into possible futures, hundreds, then thousands of possible paths. Each path is a trajectory, a potential thread through space. Some pass well outside Earth's orbit, so distant that the traveler's only a bright visitor in the night sky. A few paths curl closer, brushing near the invisible line where worry begins. These are the forbidden patterns everyone watches for. Paths that cross too close to Earth. Lines that dip inside the safe distance. Each time new data arrives, the models update. Many risky paths disappear, cancelled by better measurements. Some new ones appear and then fade. The scientists watch these patterns not with panic, but with a careful, almost parental attention. Planetary defense plans unfold quietly in the background. On Earth, there are teams whose job is to think about these days long before they arrive. They design warning systems, evacuation plans, and if needed, ways to push a dangerous object off course. Their meetings are full of charts, not fear. Checklists, not drama. They train for scenarios so that if one ever becomes real, they can move with calm, measured steps. Mars is woven into these plans now. It is no longer just a distant world in the sky. It is a platform, a listening post, an ally. Its orbiters give a second set of eyes on the unknown traveler. With their different viewpoint, they refine the orbit further, like two cameras tracking a moving firefly from opposite sides of a yard. With each joint observation, the range of possible paths grows smaller. The models become more confident, like a hand that stops shaking. If action is needed, Mars may help in other ways. From its orbit, cargo ships and probes can launch with less gravity to fight. Mars can send robotic scouts out into interplanetary space faster and sometimes cheaper than Earth. It can host telescopes in orbits that are never blocked by Earth's noisy magnetosphere or thick clouds. In the long arc of planetary defense, Mars becomes a quiet partner, an ancient traveler itself, now helping protect the younger world that once only watched it. For now, though, there is no rush to send ships. There is only watching and learning. Night after night, telescopes follow the unknown traveler as it curves inward, reaching for its perihelion, the closest point to the sun. Near that point, its tail flares brighter, a gentle banner of gas and dust. From both planets, the comet is a soft, glowing brushstroke across the black, more beautiful than frightening. On the screens, the data plots begin to settle. The risky paths shrink. The probabilities shift into safer ranges. A low murmur of relief passes through the teams, not loud enough to disturb the calm, but real enough to warm tired hearts. The narrator in your mind explains the process simply, as if tucking you in with facts instead of blankets. This is how we know what might happen. This is how we prepare, even when the risk is small. This is how two worlds watch the same sky and learn to act together. Outside, space is as silent as ever. The unknown traveler continues on its way, unaware of the models and meetings it has sparked. It comes from a realm of ice and distant nebulae, from the dark borders where comets sleep for ages. It has no message, no intention, and yet it feels like a messenger, a harbinger not of doom, but of connection. Because of it, Earth and Mars share data, share attention, share a fragile hope that if something larger ever comes, they will be ready. The hours grow late on both worlds. On Earth, the sun sets or rises, depending on where the observer stands. On Mars, the sky turns from faded blue to purple, then black as the thin air cools. Control rooms dim their lights. People stretch, close their eyes for a moment, and let the last numbers scroll by on the screens. In that drifting quiet, the unknown traveler glides on, wrapped in a soft glow, a thin veil of dust trailing behind like a memory. Its orbit is not fully fixed in our minds, not yet. There are still small uncertainties, little shadows in the graphs, places where the line could bend this way or that. The danger seems low, but not zero. The story is not finished. And so, as the night deepens and the data continues to flow like a slow, shining river, a gentle question remains, hanging in the dark between two worlds. When the time comes to choose, to act, or simply to watch, what role will Mars play in the decisions whispered under this ancient, patient sky? The silence deepens, and in that silence, something still seems to be waiting to be understood. The emergency has not vanished, but it has slowed to the pace of a deep, easy breath. Far from Earth, a fleet of spacecraft glides in patient formation. They were launched years ago, when the asteroid was only a thin scratch on telescope images, hinting at a future crossing of Earth's orbit. No one knew if they would ever be needed, but they went anyway, like quiet letters to the future. Each craft is modest, some no larger than a car, spread out over thousands of miles along the asteroid's path. Tiny thrusters whisper, correcting their trajectory by millimeters. Sensors measure starlight, heat, and the faint pull of gravity, listening to the asteroid's motion the way you might listen to a heartbeat in the dark. There is no roaring engine, no bright explosion. Instead, there is patience. One craft hovers beside the asteroid, using its own gravity as a gentle tug. Another slips slightly ahead, adding the softest pull, like a guiding hand on a shoulder. A third releases a thin cloud of reflected dust, changing how sunlight pushes on the surface. The cosmic dance is made of nudges, not blows. Tiny changes in trajectory that, over millions of miles, can mean the difference between impact and a harmless pass. On Earth, the asteroid's name scrolls quietly across screens, tucked among weather maps and morning headlines. Its updated path appears as a thin curve looping near our planet in soft colors. There are no crowds in the streets, no panicked shouting. People still go to work, make dinner, laugh with friends, and fall asleep under the same glow of city lights and stars. For years, governments, scientists, and communities have prepared together. Quietly, without sirens, they have turned mines, mountain caverns, and deep basements into shelters. Some are simple reinforced rooms with water and air. Others are layered underground neighborhoods with gardens and long halls where people can walk in shirt sleeves. They are not built out of panic, but out of a steady decision. If the sky sends a test, humanity will answer with care, not chaos. Beneath red dust on Mars, habitats curve into the planet's crust. Tunnels have been melted into rock, then sealed and pressurized. Stone and soil form a shield against solar wind and cosmic rays. Inside, air moves in slow currents, and plants grow in narrow beds. Fans and pumps hum softly, weaving a bubble of life where none existed before. Outside, the Martian sky is a gentle rust color, a drifting veil stirred by ancient winds. Above that sky, unseen, the same asteroid passes on its inward path. The people living below know this. They follow updates from orbit, but do not crowd at windows or shout at the sky. Their calm is a skill they build, day after day. In one red refuge, a child traces orbits on a wall screen with a fingertip. A line for the asteroid, a line for Earth, a line for Mars. The paths curl around the sun in neat loops, a slow spiral of time and distance. Nothing in space moves in straight lines for long. Gravity bends every path into a curve, turning falling objects into a dance. Will it hit us? The child asks. It might, comes the answer, or it might not. That's why the spacecraft are already there, and why these shelters are ready. We cannot command the whole sky, but we can prepare our little corners beneath it. Above them, in the sky, they cannot see. Sunlight warms one side of the asteroid while the other cools. Over years, that uneven heating twists its motion, a subtle push called the Yarkovsky effect. The fresh dust from the spacecraft makes that effect a little stronger, like changing the texture of a sail. It is almost nothing, but across deep space, even that can grow into a distance wider than Earth itself. On Earth and in orbiting control rooms, people watch numbers instead of pictures. Position, speed, angle. The asteroid's path is recalculated again and again. Each tiny deflection shows up as a small change in predicted distance. With each update, a bit more room opens between our world and the narrow corridor where impact would occur. The emergency is still there, the future still uncertain. But it is no longer a sudden blow from nowhere. It has become a question answered in slow motion, one decimal point at a time. As you listen, your own thoughts may begin to match that slower pace. The word asteroid might once have pulled your mind towards scenes of fire and dust. Now the images soften. You see careful work, human patience, and the quiet strength of planning far ahead. Under this softer light, fear changes shape. It becomes focus. On Mars, one shelter lies deeper than the rest, carved into a canyon wall where stone is thick and cool. In the central room, people gather around a projection of the asteroid's orbit. It hangs in the air like a glowing thread, passing near the circle of Earth, but no longer crossing it, if the newest calculations are right. Some are engineers, some tend the gardens, some are children who have never seen an Earth sunrise. Each is part of a fragile thread of humanity stretched across two worlds. If the worst were to happen, if the asteroid struck Earth despite every careful nudge, these shelters would hold memories of oceans, forests, and blue skies. They would carry stories of birds and rain to a planet that has only known dust and thin air. The narrator turns to energy now. The asteroid carries kinetic energy, built up over eons as it falls around the sun. The spacecraft hold only a fraction of that, yet directed with care, their small pushes can shift the ancient rock's path. It is not a battle, not a clash of enemies, but a quiet adjustment to the steps of a dance that began long before humans looked up with wondering eyes. Solar panels unfold on the ships, drinking in sunlight and turning it into power for each maneuver. On Mars and Earth, other panels do the same, feeding energy into life support, heaters, recyclers, and antennae. The same starlight that could light an impact also lights gardens and rooms where children sleep. Night after night, under different skies, people rest while telescopes and computers stay awake. Instruments track the asteroid's tiny shift against the background of distant stars. Antennae listen for signals from the fleet, a soft stream of data crossing the void. The emergency rests in many minds at once as a shared responsibility. You breathe in and out, matching that slow rhythm. The asteroid moves. The spacecraft adjusts. Earth turns. Mars turns. The sun burns steadily at the center, holding these orbits like invisible threads. In that grand pattern lives the possibility of impact and the growing possibility of a miss. Both are real, for now. Both belong to the same unfolding story. If the danger passes, as the planners hope it will, there may be no single day of fireworks or grand speeches. There will only be a quiet realization, spreading through calm headlines and early morning messages, that the latest calculations show a safe distance. The asteroid will drift by. The sky will look unchanged. Life will continue with its small troubles and soft joys. Perhaps you will remember this slow, imagined emergency, held like a bedtime story in your thoughts. You may recall tiny ships nudging a great rock, refuges glowing beneath stone, Mars waiting as a red shelter for a fragile thread of humanity. And as the danger, real or imagined, fades into the background of your mind, a question may remain. Faint but steady, when the sky grows calm again, whether in the world above you or only in dreams, what memories and lessons will you choose to carry forward? Like a small, enduring light along your own quiet path through the dark? The danger has passed. Far above both worlds, the ancient traveler is gone. Whether it burned to ash in a bright sweep of atmosphere, or shifted just enough in its trajectory to glide harmlessly past, the result is the same. Earth and Mars are still here. The storm is over, but the sky feels different. On Earth, night has settled like a gentle veil. Cities dim their lights a little more than usual. Some do it to let the telescopes finish their work. Others do it because they want to see the sky clearly, maybe for the first time in years. Streets are quieter. Windows are open. People step outside, pull on jackets, and tilt their heads up. Above them, a brushstroke of stars is spread across the dark. The Milky Way is a faint river of light. A few satellites creep along their orbits, tiny moving sparks. In parks and on rooftops, in farms and on balconies, people gather in small clusters. Parents stand with sleepy children. Neighbors who hardly ever speak share thermoses of tea. For a long time, no one talks about work or traffic or money. They talk about the comet. They talk about the near miss. Can you believe it? Someone whispers. We're still here, answers another. The fear that filled the days before, the breaking news, the worried maps, the countdowns has softened into something quieter. It is not excitement anymore. It is something closer to gratitude. The planet did not end. The oceans still move. The forests still breathe. The cities still hum. Over and over, people look up and feel a strange mix of smallness and safety. They know now in their bones how fragile all of this really is. Somewhere in a quiet observatory on a mountain, a telescope is already searching again. Its mirror, polished to perfection, drinks in starlight. It studies the paths of rocks, the distant drift of other small bodies in orbit around the sun. Hidden in its data is the memory of this near disaster, and they promise that next time they will see earlier, measure better, act faster. The crisis has turned into a teacher. On Mars, the sky tells another story. Here, the night is thinner, the stars sharper. The air is cold and dry, more silence than substance. Above the red plains and dark cliffs, the constellations are the same as Earth's, but they feel different. They feel closer, as if the universe has stepped nearer to listen. Near the edge of a crater, under the transparent arch of a habitat dome, a group of settlers gather by the main viewing window. Their boots are dusty. Their faces are tired. They have spent days checking seals, scanning systems, running emergency drills they hope never to use. Now, they stand shoulder to shoulder and peer up through the glass. There, just above the horizon, is a faint blue point. It is not the brightest star, not the largest. But every person in the dome knows exactly what it is. Earth. From Mars, their home planet is only a distant dot, a tiny glow against the black. It looks delicate, almost too fragile to hold everything it carries. Oceans, forests, cities, memories. The settlers think about their families under that other sky. They think about how close things came to silence on both worlds. For them, the near miss is not just a news story. It is a shadow that passed directly over their lives. One engineer remembers running the numbers on the impact models, watching the lines on the screen tighten like a fist. A botanist in the greenhouse remembers checking plant roots with shaking hands, wondering if any of this would matter in a week. A teacher in the small classroom held a lesson about comets, trying to keep her voice calm while the children drew the solar system with crayons. Now, with the danger gone, their fear melts into something else. They feel exposed but also connected. They gaze at that faint blue point and understand, more clearly than ever, that everything there came from there. Their stories, their languages, their music, even their worries all launched from that world and crossed tens of millions of miles to arrive in this dusty outpost. On this side of the sky, Mars is no longer just a quiet harbinger of doom in old science fiction tales. It is a shelter. It is a listening post. It is a second chance. Between these two skies, a fragile bond tightens. Radio waves slip back and forth between planets, carrying voices turned into numbers and then back into sound. There are official calls leaders speaking to councils, scientists sharing data, teams reviewing the final path of the comet. And there are private calls, A father in a small apartment on Earth talking to his daughter in a Martian habitat. A sister on Mars reassuring her younger brother back home that she's still okay. Did you see it? Yes, from here it was small, but still scary. Are you all right? I am if you are. Across this distance, words feel heavier. Every good night carries the weight of what almost wasn't. Every talk to you tomorrow now feels like a promise, not just a habit. The near miss has given both planets something that statistics alone never could, a shared memory of almost losing everything. Science returns, not with the sharp edge of panic, but with the gentle rhythm of waves on a shore. In labs on Earth, computers hum as new orbit models are written and tested. The old ways of tracking near-Earth objects are carefully examined, improved, and layered with fresh tools. Dedicated telescopes are assigned to watch the dark more closely, searching for any rock, any icy fragment, any anomaly that might become a threat. Spectrographs read the colors of starlight to learn more about distant asteroids and comets, measuring what they are made of, how dense they are, how they might react to a push or a blast. The data is cool and precise, but behind every chart is the warm, human memory of fear and relief. On the moon, small robotic telescopes swivel in slow arcs, free from air and weather, keeping an unblinking watch. On Mars, the settlers add a new array of sensors along the ridge above their dome. The dusty robots that once only surveyed rocks and soil now send a fraction of their time to scan the sky as well. New orbiters are planned. A network of satellites, stretching from the inner solar system to its outer edges, is imagined and then designed. The idea is simple. If the universe sends another cosmic whisperer, messenger of ice and stone, the planets will hear it sooner. Mars, once a red warning light in the human imagination, becomes something else, a partner in the watch. The change is not only technical, it is emotional. On Earth, more children sign up for astronomy clubs. They learn the names of nebulae and exoplanets, trace the curves of comet tails, and understand words like trajectory and orbit before they finish middle school. They do this not because a teacher tells them to, but because they want to know what might be coming their way from the darkness. On Mars, lessons in the tiny classrooms blend stories of pioneers with the physics of impact craters. The students walk outside in pressure suits and stand on the rim of a real crater, carved by an ancient collision long before humans arrived. They press gloved hands to the rocks and feel, through layers of fabric and plastic, the deep history of violent moments that shaped the worlds. In both places, people no longer see Mars as just the other place. It is not only a red dot on star charts or a dusty backdrop for dreams. It is a mirror and a partner. Earth holds most of humanity. Mars holds a small, brave fraction of it. Both now understand that they are part of the same fragile system, moving together around the sun. In the quiet after the storm, you are invited to imagine something gentle. Picture a child on Earth, years from now, curled in bed while the night presses softly against the window. A calm voice tells the story of the near-miss comet. The words move slowly, steady, and soothing, describing the ancient traveler of ice, the careful telescopes, the almost disaster, and the relief that followed. Far away, under a thinner sky, imagine a child on Mars. Outside their habitat, the red dust sleeps in the low gravity. Stars are sharp and steady above the dome. Inside, the air is warm and faintly metallic. This child lies in a bunk built into the wall, listening to almost the same story. The names are the same. The comet is the same. The feelings, fear, wonder, gratitude are the same too. Two planets, two beds, two small listeners under two very different skies. And yet, through that shared story, they are closer than the miles suggest. In that calm moment, the near-miss becomes more than an event. It becomes a bedtime tale, a lesson wrapped in a dream. A reminder that danger and hope can exist side by side, that science and wonder can hold hands. The comet has gone. The alarm has faded. The data is stored. The models are refined. Life, in all its messy beauty, continues on both worlds. But a question now drifts quietly between Earth and Mars. Like a soft glow at the edge of night, if Mars is no longer only a harbinger, if it is now a partner and a refuge, what deeper, timeless meaning does this red world hold for humanity's destiny? The skies offer no quick answer. They simply shine one blue, one red, while, in the drifting quiet between them, the question waits, gentle and awake, for whoever dares to listen. High above Mars, the camera moves slowly, as if careful not to disturb the silence. The planet rolls beneath like a dim, rust-colored ember, half in shadow, half in a soft glow of scattered starlight. No engines roar now. No busy music fills the air. Only the steady drift of an ancient world turning in an endless night, wrapped in a gentle veil of darkness and dust. The craters come first. They look like frozen ripples, rings pressed into the planet's skin by long-gone comets and asteroids. Each crater marks a moment when something from deep space met this quiet world at great speed. Once, these impacts were violent, bright, and loud. Now, they rest in stillness, their sharp edges softened by time and wind. The camera glides over them without hurry, letting you feel how old Mars is and how patient. Beyond the crater fields, a canyon opens beneath you. Valles Marineris, so long it could stretch across an entire continent on Earth, lies in deep purple shadow. Its walls fall away into darkness, layer after layer of rock carved by forces that once shook the planet. Dust hangs in the thin air like drifting shadow. Down there, the cold is sharp and deep, but from above it looks like a peaceful scar, a memory written in stone. Farther north, the polar caps glow with a faint brightness, like a nightlight at the edge of the world. Ice, dust, and frozen carbon dioxide lie in quiet rings, expanding and shrinking with the seasons. Under starlight, they resemble the pupil of an eye, half open, watching. This is a planet that never sleeps, even though nothing moves that you can see. It always rotates, always orbits the sun, always keeps its silent watch. Mars has been our distant neighbor for as long as humans have looked up. Through early telescopes, it appeared as a tiny reddish dot, shifting along a strange, looping trajectory in the sky. At first, it was just a wandering star, an unexplained anomaly. Then, sharper lenses revealed dark patches, bright caps, thin lines that stirred wild guesses, canals, oceans, maybe even life. The planet became a mirror for our hopes and fears, a harbinger of what might lie beyond Earth. When spacecraft finally reached it, the story changed again. In the past, probes and rovers rolled over this ground, measured its soil, and tasted its thin air. Spectrographs examined the light bouncing off rocks and dust, and found signs that water once flowed here. Dry riverbeds, ancient lake basins, minerals formed only in liquid water. These discoveries told of a Mars that was not always this quiet. Long ago, it may have known clouds and rain, perhaps even a soft glow of sunrise over shallow seas. Yet now, the seas are gone. The planet is bare, exposed to space. Its atmosphere is so thin that a gentle breeze feels like almost nothing. Radiation streams down from the sun and from distant explosions in the galaxy, mostly unblocked. Daytime brings a weak sunlight. Night brings a deep, bone-cold chill. In this harshness, Mars has become our teacher. It shows us what can happen when a world loses its shield, when air thins and water fades away. As we study Mars, we learn how fragile our own planet really is. Our telescopes, orbiters, and landers track dust storms that can grow to wrap the entire globe. They measure how the atmosphere escapes, bit by bit, into space. They map old shorelines and dried-up deltas that whisper about climate shifts long past. By looking at Mars, we see an echo of futures we hope to avoid. It is as if this quiet world has quietly prepared us for the worst by showing us what is possible. But Mars is not only a warning. In its colors and shapes, there is deep beauty. At night, starlight pours over the landscape like a soft silver mist. The plain stretches toward the horizon, smooth and endless, broken only by low hills and the faint outline of a distant volcano. A small, robotic rover sits motionless, long since powered down. Its tracks, half filled by dust, curve away into the dark. Even in stillness, the scene feels full of gentle wonder. Above Mars, the sky is black, truly black, not the dark blue you know from Earth. Against this dark, the universe opens like a vast, silent ocean. Distant stars burn with steady light. Nebulae glow as faint colored clouds, where new stars are born from swirling gas and dust. Galaxy clusters hang far beyond, scattered like islands of light in deep space. Black holes lurk in some of those galaxies, invisible yet powerful, bending space and time around them. Here, they are not monsters or threats. They are part of the backdrop, quiet and far away, like distant waves on a shore you can barely hear. Mars circles the sun on its calm orbit, and above it, the universe continues its slow dance. The great forces, gravity, radiation, cosmic rays are all at work. But from this vantage point, they feel like background music. Soft and steady, guiding every comet, every exoplanet, every drifting grain of dust along its path. As you drift with the camera, you may feel yourself slipping into the rhythm of this place. Your thoughts slow to match the turning of the planet. Each Martian day, each orbit, each season unfolds at its own quiet pace. The rush of daily life on Earth fades, replaced by something simpler, the steady spin of a world lit by a distant sun, wrapped in night on one side and pale morning on the other. In that calm, Mars becomes both memory and messenger. Memory, because it holds the story of what it once was: warmer, wetter, more active. Messenger, because it sends us information across millions of miles, data turned into images, numbers turned into knowledge. Every signal from an orbiter, every pixel from a camera, every curve in a graph is a small cosmic whisper. This is what happened here. This is what a planet can become. Scientists listen closely. They model how atmospheres thin, how magnetic fields fade, how surfaces crack and crumble. They compare Mars to Earth, and then to other worlds' rocky exoplanets circling distant stars, worlds we have not yet seen clearly, only hinted at through tiny dips in starlight. What we learn from Mars becomes a guidebook, a way to read the fates of planets far beyond our own sky. And you, listening in the dark, become part of that story too. Somewhere, your planet spins under its own night, clouds drifting, oceans breathing, cities glowing. While you rest, telescopes continue to track Mars. Spacecraft continue their orbit. Computers continue to sift through signals from the red world and from the deep sky beyond it. The work goes on even as your eyes close, and there is something comforting in that steady, patient watching. The documentary's pace slows even more now. The view pulls back until Mars is only a small sphere again, hanging in the black. Its deserts, canyons, and polar caps are still there, but they blur into soft color and shadow. The planet looks almost like a memory, something half remembered from a dream. Behind it, stars shimmer like grains of distant sand, and faint smudges of light hint at galaxies far beyond your reach. Mars stays there, a quiet guardian in the endless night. Not loud, not demanding, just present. It guards our questions about life, about loss, about survival. It guards the lessons we pull from its rocks and dust. It guards, too, the sense of awe that rises whenever we send a new mission, land a new rover, or see a new image come to life on a screen. This small world has changed us simply by being there, waiting to be understood. As your breathing slows and your thoughts grow softer, the universe around Mars seems to exhale as well. The light from distant nebulae travels on, passing the planet without a sound. The gravity of unseen black holes pulls on stars that will never know they are being moved. Galaxy clusters spin, far away and unconcerned, while this single red planet follows its orbit like an ancient traveler, faithful and calm. The story does not end here, not really. Tomorrow, new data will arrive. A new comet will pass by some distant star. A new exoplanet will be found circling a quiet sun, its orbit traced in the tiniest of dips in starlight. We will go on learning, adapting, surviving, guided in part by what Mars has already shown us. The night is endless, but so, too, is our curiosity. And as the last image of the planet fades into a cradle of silence, there is a feeling soft and almost hidden somewhere in that vast dark. Another world is watching with us, waiting for its turn to whisper its secrets into the quiet.